All right, guys, we're going to be talking about 7.5 rational exponents and radicals. This is kind of a follow up to what we did yesterday. It is actually the last section in this chapter, but it does bring in some new information. Okay, so I want to really go through this with you and make sure that you have an understanding of what we're doing. So, we're talking about 7.5 rational exponents and radicals. So, there is a distinct relationship between rational exponents and radicals that we want to kind of look at. So let's start with this. Let's start with the square root of 9, okay? So the square root of 9, when we say that, there's a couple of different things we're saying. We're saying what number times itself will equal 9, okay? That's really what you're asking. And so we know by now that the square root of 9 would in fact be 3, okay? Because 3 times 3, or 3 squared, will give us an answer of 9, okay? There's another thing we need to think about is that this particular one that we just wrote out here, we call that the square root of 9, but you can actually take different types of roots. So in other words, I could also look at, let's say, the third root of 8, okay? So in this case, this 3 indicates, it's kind of the index that indicates what kind of root I'm taking. And then I'm doing this to the number 8. So I'm asking myself this time, what number times itself 3 times will actually equal 8? Well, in this case, we know that that would be 2, because 2 to the third, or 2 times 2 times 2, would in fact be 8. Okay, 2 times 2 is 4, 4 times 2 equals 8. So our answer for this particular question would be 2, okay? One of the things we need to think about then when we're talking about square roots is there's actually a number right here. Even though we don't see it, it's really still there. So let's think about this. There is a number 2 right there. Okay. The other thing you need to think about is there is a number 1 right here. Okay. So we notice that 9 raised to the first power would in fact be 9. That doesn't really change the problem. And then I'm taking the square root, which means there's a 2 as an index right here. So now let's just kind of examine the number 9 itself. And I want to show you something here. So if I take 9 squared, that is in fact going to equal 81. Okay. And then if I look at 9 to the first power, that is going to equal 9. And then 9 to the 0 power equals 1. So we got to think to ourselves, how in the world what exponent could I raise 9 to that would get me to 3? You notice 9 to the first is 9, 9 to the 0 is 1, so it's got to be in between here somewhere, okay? So this is where you can actually take this rational exponent and you can or this radical rather, and make it a rational exponent. So let's look at this real carefully. If I take again the square root of 9, I can actually rewrite that as 9 to the 1/2 power. So what happens is the power that this is raised to becomes my numerator, and the index that this is being used becomes my denominator. You're going to think, well, that's crazy. That don't make any sense. Well, watch what happens here. We're going to go to Desmos. And you notice if I go ahead and put in 9, and here I've got this a raised to the b, that allows me to put in whatever index I want. So I'm going to go ahead and choose that, and I'm going to put 1 divided by 2. You notice 9 to the 1/2 power actually gives me the answer of 3. The same thing that would happen if, for example, I did, square root, let me move this out of the way just a second. The square root of 9, notice, is also the answer of 3. So again, you can write these radicals as rational exponents. And so the same exact thing is true. For example, if I had 25 to the 1/2 power, that would be the same thing as saying I could go ahead and make my radical sign, go ahead and put 25 is the part that goes underneath, okay? The 1, remember, I got that from what was on the inside. And so the 1 would go right here. The 2 in this, the denominator, would be my index. And so I end up with 25, the square root of 25, which actually equals 5. Okay? So now let's look at some live examples, and I think that will really help us to be able to figure out what we need to do on this particular practice. Okay? See if I can get this thing moved back down. Yes. All right. So if we look at this particular example that we have right now, okay, we have x to the 3/5 power, and it's asking us to write this expression in radical form. And so what I want to do first is I want to go ahead it is not wanting to let me write on this for some unbeknownst reason. It is being ornery. I don't know what's going on. All right, for whatever reason, my pen decided to quit, so I'm just going to go ahead and use my finger, I guess, from this point. So it may be a little messy, but it's all right. So we've got x to the 3/5, okay? So again, the first thing I'm going to do is I'm going to go ahead and put my square root symbol, my radical symbol. And remember this number here, we kind of call that our base, is going to go on the inside. So I'm going to go ahead and put x right there. Remember that this numerator here, right here, is going to go inside underneath the radical. Okay, so we're going to have x to the 3rd. Boy, that looks really sloppy. But again, I'm trying to use my finger. So, and then the last, but certainly not least, is this denominator right here is actually going to go right here as my index. Okay, so if again you look at this, you're going to hopefully see that answer. The 5th root of x to the 3rd is the way you really read that. So there you can see that particular answer is option number 4. Okay, so you're going to do the same thing on number 2. It's not really any different. This one you're going to do the same thing again. Okay, you're just going from an exponent, a rational exponent, to a radical. So let's go on down to a different type problem. So we've got number 4, and here on number 4 again. This time you are given a radical and you're asked to express it in exponential notation. So again, we're going to take this base right here, which is c, and I'm going to go ahead and just write that right here, c. Notice that this 4 actually becomes my numerator. So again, I'm going to put the 4 here, put my fraction bar, and then the 3, which is the index, actually ends up being my denominator. Okay, pretty simple, but you got to be able to go back and forth between rational exponents and radicals. Okay, so now let's go down and maybe look at a different one. So those are basically going to be the same. Remember, this would be b to the 1st power. So again, I'm just going to bring out b. 1 is going to become my numerator. Sorry, I don't know why I put that equal sign there. I did not need that. And then again, 4, or my index here, would be my denominator. All right. So let's go down and look at a couple more. Okay, so the 3rd root of 125. This one may be, in particular, something that you've never seen before. So let's go back over to Desmos real quick. And I'm just going to add myself a new line here. And I'm going to go ahead and put square root symbol. And you notice that it's trying to do the square root, which is not really what I want, okay? So let's see if we've got any other options here for this particular thing on this calculator. Let's go to functions. And you notice right here under miscellaneous, okay, I'm going to move this out of the way again. The thing just keeps getting in the way. But you notice right here, I have an option that allows me to put a certain index there. Okay, so what I'm going to do, I'm going to go ahead and delete all this out. And I'm going to do this again so that you can see what we're doing. Okay, all we're doing is we're choosing functions here on the calculator. I'm sorry that keeps popping up. And we want to go right here underneath the percent symbol. And you notice that option that allows you to choose different values to put in there. Okay, so we were looking for the 3rd root of 125. And notice what happened. It gave me the answer of 5, okay? So what you're really saying when you're asking that question, the third root of 125, you're really saying what number times itself will equal 125, and that would be 5, okay? Because again, 5 to the third is the same thing as 5 times 5 times 5, which in fact does equal 125, okay? So this would be our answer. You just put in the number 5. All right, so let's go on down and look, see if there's anything else we've got here. What is the value of the expression below? Again, remember Desmos could be your best friend here. It will definitely help you to be able to put these things into the calculator and get out a numerical answer, okay? So you can literally, like for number 12 in Desmos, put in 32 raised to the 4/5 power. Remember that you can just use your A, B right here, and that will allow you to raise anything to a certain power. Okay. Hopefully this has been helpful. Again, some new information, so you're learning some new stuff. And this is, in fact, the end of the chapter. So we'll be doing a review and a test coming up shortly. Again, if you need help, make sure that you ask us. Okay. Thanks.